All right, getting ready for the Chapter 7 Part 2 test. And this is the practice test in your notes. And the first page on this, we are establishing identities. All right, so in this first problem, the biggest thing here is we're looking to see what kind of function this might be in terms of even or odd. And tangent is an odd function, so will the reciprocal of tangent be. So this is the same as 1 plus negative cotangent of the angle squared. So when I square that negative, I'm going to have a positive. So this is just 1 plus cotangent squared of the angle, and this is an identity, and this is secant squared. I'm sorry, cosecant squared. All right, so we're looking to show that the left side has the same value as the right side. In number 2, I have tangent and cotangent. Now these are reciprocals. I can write tangent as, I can write cotangent as 1 over tangent. And then we have minus cosine squared of the angle. So the tangents are going to cancel. A tangent times its reciprocal. This is just 1 minus cosine squared of the angle. And this is the identity. If we do sine squared plus cosine squared equals 1, I can subtract cosine squared, and 1 minus cosine squared would be the same thing as sine squared. And that's what we have here. Number 3, I'm looking at secant to the 4th power and secant squared. So I'm gonna see if maybe I can factor out a secant squared, and this would be secant squared minus 1. And if I just check with FOIL, I get back to secant 4th minus secant squared. Well, secant squared has an identity of tangent squared plus 1. So if I have secant squared here, I'm also going to have a tangent squared plus 1 and then a minus 1. Okay, so I changed both of our secants here to tangent squared plus 1. So here, my 1 minus 1 is going to cancel. So this is just tangent squared times the quantity tangent squared plus 1. And if I distribute, because this is really what I have left, I have tangent to the 4th power plus tangent squared, which is what I have on the right side. On number 4, I see I have a 1 minus cosine of an angle on the denominator of sine squared. Well, I know that sine squared is the same thing as 1 minus cosine squared. So I'm just writing everything out except for I replace sine squared with 1 minus cosine squared. Now on the top I have the difference of squares, so I can factor this. So this is 1 minus, and on the numerator I have 1 minus cosine of the angle times 1 plus cosine of the angle over 1 minus cosine theta. So here I can cancel my 1 minus cosine theta, and I'm going to have 1 minus 1 would give me 0, and then I've got this minus here that I'm actually distributing, so this is minus cosine of theta. Which is what I have up on top. Number 5. It looks like on this one, maybe I should get a common denominator. If I am adding fractions together and I'm ending up with one term, I'm going to have to put this all in one term. So I am going to have a common denominator that has a cosine of theta and 1 plus sine of theta. Now, to get the common denominator, I need to multiply the first fraction by a cosine of theta and the second fraction by a 1 plus sine of theta. Okay. So this first part is cosine times cosine, which is cosine squared of theta. And then I'm going to FOIL this. So I have 1 times 1 is 1, 1 times sine theta, another 1 times sine theta is plus 2 sine theta. And then I have a plus sine squared of theta. All right, so noticing that cosine plus sine will give me a 1. So I'm left on top with a 1 here. Sine squared plus cosine squared is 1. So that gives me 1 plus 1 is 2 plus 2 sine theta over cosine theta and 1 plus sine theta. Now here I can factor out a 2. And I have that factor of 1 plus sine theta. And the cosine, I forgot here. So the 1 plus sine thetas will cancel out. And I'm left with 2 over cosine of theta. Or sometimes I like to write this separate. 1 over cosine of theta. And I know that this is secant. So this gives me 2 times secant of theta, or 2 secant theta. Number 6. Here I've got lots of secant, tan, cotangent. Let's put this in terms of sine and cosine. So secant would give me 1 over cosine. And tangent is sine over cosine. Then on the denominator, I have cotangent, which is cosine over sine, and then plus cosine. All right, so now if I get a common denominator on the top and bottom, this is like cosine over 1. So on the top, my common denominator would be cosine, and on the numerator, I've already got this common denominator, so I have 1 plus sine. Then on the bottom fraction, I have a sine and then a 1, so my common denominator would be sine, so I need to multiply by sine over sine. So this is going to be cosine plus cosine sine. Now, if I multiply by the reciprocal, and while I'm doing that, I'm going to factor out a cosine in this as well. So this could be factor out a cosine, and then I'd have 1 plus sine. All right, so when I flip it over, that's how I'm going to write it. So I have 1 plus sine on the top over cosine. I'm going to multiply by the reciprocal, so sine goes on the top. And then this is where I'm going to factor out a cosine, and then a 1 plus sine. All right, so it's nice that these 1 plus sines will cancel, and I'm left with sine over cosine, and this is tangent, and then I have 1 over cosine, and this is secant. So this gives me secant of theta times tangent of theta. That's not divided by, I shouldn't write it like that. How about secant theta tangent theta, which is what I have here, just in reverse order. So that is equal. On number 7, let's see here. I have sine and tangent. Let's put tangent in terms of sine and cosine. So I have sine squared of theta minus sine over cosine. And then I have cosine squared of theta minus cosine over sine. All right, so this is where I want to get a common denominator on the top and a common denominator on the bottom, and then I can multiply by the reciprocals. So my common denominator on this top fraction is going to be cosine, and to get a cosine here, I need to multiply the top by cosine. So I'll have sine squared cosine minus sine. And then on the denominator, I'm going to have a common denominator of sine. And to get a sine here, I need to multiply by sine on top. So this will be cosine squared sine minus cosine. Now, I can look here and I can factor out a sine in these, each of these here. I think that's what I want to do. I can factor out a sine. And I'll have sine cosine minus 1 over cosine. And then I'm going to multiply by the reciprocal, so I'm going to have a sine here. Whoops, it's not squared. But I can multiply out a cosine on each one of these. So this would be cosine times sine cosine minus 1. Now this will cancel, and I'm left with sine squared over cosine squared, which is tangent, and that's what I wanted. All right, so I wanted that tangent at the end. On number 8, we have sine of the sum of angles. So let's just assume we're going to use our angle formulas. So for sine, I'm going to have sine of A times cosine of B, and we keep the same sign. Then I have cosine of A, sine of B. On the denominator, I'm going to have cosine A, cosine B. So when I have two factors on the denominator and two terms on the numerator, oh, I'm so sorry. I might want to break this up into two fractions. So I'll have sine of A cosine B, whoops, over cosine A cosine B. And then I'm going to add this term over the common denominator. So cosine A sine B over cosine A cosine B. All right, so what this looks like is my cosine B's are going to cancel here. So I have sine A over cosine A, and that's going to be tangent of A. And over here, I can have my cosine A's cancel, and I have sine over cosine of angle B. So that's plus tangent of B. All right, so hopefully verifying these identities are starting to get a little bit easier for us. Looking on the second page, here we have, they tell us we have sine of an angle is 6/10, and that angle is between pi over 2 and pi. So that tells me this is quadrant 2. So I need to find sine of twice the angle. Now, if I look at the formula here, sine of 2 theta is the same as 2 sine theta cosine theta. So I need to draw a picture of this so that I can find cosine. So in quadrant 2, right here, here's my angle. Here's my right angle. My sine is 6 over 10. So side adjacent is, side opposite is 6, and hypotenuse is 10. And if I do the Pythagorean theorem, this is going to tell me my y value, which is going to be a negative value here, because cosine is negative in the second quadrant. I am going to have 6 squared plus y squared is 10 squared. So that's 100 minus 36. So y squared is 64. So this is 8. So this is negative 8. And cosine is going to be negative 8 over 10. So now if I plug those values in here, I have 2 times sine, which is 6 over 10, and cosine is negative 8 over 10. And if I multiply these together, I'm going to have 6 times 8 is 48, times 2 is 96, so that's negative 96 over 100, or negative 24 over 25. Then it says to find cosine of the half angle. All right, so if we use the formula for that, that's going to be plus and minus square root of 1 plus cosine of the angle over 2. All right, and because this is in quadrant 2, cosine is going to be negative. so I want to use that negative value. So I have minus the square root of 1 plus cosine is negative 8 over 10 over 2. So this would be 2/10 or 1/5, because this would be 10 over 10. Minus 8 over 10 is 2 over 10 or 1/5 divided by 2, which is the square root of 1/10. And this would be, if I rationalize the denominator, square root of 10 over 10. Number 9 says to use the half angle formula to find the exact value. So the half angle formula, and we're going to use minus, I'm looking for the half angle formula. So I have 1 minus cosine of theta over 2. Now, if I think about this angle as being a half angle, I need an angle over 2. So the angle that's divided by 2, that's going to give me this value, is negative pi over 3. Negative pi over 3 divided by 2 is negative pi over 6. All right, so the angle that we're looking at is negative pi over 3. And if I look at the cosine of that value, I get negative 1/2, or I get 1/2, sorry. So this is the negative value of 1 minus 1/2 over 2. So this is negative square root of 1/2, 1 minus 1/2 over 2 is the square root of 1/4, which is 1/2. And the negative value. In part B, I'm looking for the cosine of 22.5 degrees, and I'm doing this as a half angle. So this would be the same thing as my angle being 45 over 2. Okay, so when I'm looking for cosine of the angle, I'm looking at cosine of 45. So my formula, and by the way, this 22.5 degrees is in quadrant 1, so I'll use the positive value of the square root, and I have 1 plus cosine of my angle divided by 2, which is 1 plus the square root of 2 over 2 divided by 2. Now I can, let's make this a common denominator on top. So this is the same thing as 2 over 2 here. So I have the square root of 2 plus the square root of 2 over 2 divided by 2, which would be divided by 4. Okay, so this would be a 2 on the bottom, and then multiply it by 2 again, and I get 4 on the denominator. And I think I'm just going to leave it in this form. Probably if you gave me this, I would accept that as well. Number 11, it says if it's known that sine of alpha equals 5 over 13 and sine of beta is negative 3/5, find the exact value of cosine of the difference of the two angles and then sine of the sum of two angles. All right, so we know sine for each of these, so I need to find cosine. So in this first angle, it has to be between 0 and pi over 2. So it's going to be in quadrant 1. So I'm going to draw a triangle in quadrant 1. Here's my angle alpha. Sine is opposite over hypotenuse. And oops, I'm getting ahead of myself here. That's 13. And there is a Pythagorean triple, 5, 12, 13. And if you're unsure of that, you could do the Pythagorean theorem. But I want to find cosine now. So if sine of my angle is 5 over 13, cosine of angle A is going to be 12 over 13. Now for angle B, this has to be between pi and 3 pi over 2. So I can draw another triangle over here, but since this is in the third quadrant, I'm just going to save space and draw it in the on the same unit circle. So this says sine is negative 3 over 5. So if this is my angle B, this is negative 3, my hypotenuse is 5, and this would be a 3, 4, 5, and this is also negative 4 here, and my hypotenuse is positive 5. All right, so I have sine of B is negative 3/5, and cosine of B is adjacent is negative 4 over 5. All right, so if I am finding cosine of A minus B, I'm going to have cosine A, cosine B, change the sign to a plus, then I have sine A, sine B. Now if I put those values here, cosine A times cosine B. Cosine A is 12 over 13. Cosine B is negative 4 over 5. That comes from over here. And then I'm going to add sine A is 5 over 13. And sine B is negative 3 over 5. Multiplying these together, so I have two parts here. 12 times 4 that's negative 48. 13 times 5 is 65. 5 times 3 is 15. That's negative over 65. Now I'm going to add my 48 plus 15. These are both negative, so I'm going to add them. And this is negative 63 over 65. So the formula for sine A plus sine B, here we'll have sine A cosine B, same sign, plus cosine A sine B. All right, now I'll put my values in. Sine A from back over here is 5 over 13. Cosine B is negative 4/5. Plus cosine A, 12 over 13. Times sine B, and that's negative 3/5. 5 times 4, that's negative 20 over 65. This is negative 36 over 65. Add these together, I get negative 56 over 65. All right, next one, they're asking me to find the exact value of this here. So I have a sine A cosine B, cosine A over and multiplied by sine B. So this actually is a sine formula. My first value is 30. My second value is 60, and sine will keep the same side, sine. So this is sine of 90, and to find the exact value, sine of 90 is 1. Next one, when I have cosine, cosine, sine, sine, I'm going to have a cosine. My first angle is 130. My second angle is 10, and it's the opposite sign in between them. So this is cosine of 120. And if I look at my unit circle, this is in quadrant 2. This has a cosine of -1/2. All right, getting towards the end here. Number 14. I have sine of an angle divided by 2. So I'm going to use the half angle formula. And in the half angle formula, when I have sine, I have the formula plus and minus, and I think there's a typo over here. This actually covers -pi/2 is -90 and 0. So this is -90 and 0. This is quadrant 4. So it's not a typo. So it's just a negative value here in quadrant 4. So I want sine of alpha or a over 2. So I'm going to look at 1 minus cosine of the angle divided by 2, and cosine of the angle is 5/12. So this is negative square root 1 minus 5/12 over 2. So this is 12/12 minus 5/12 is 7/12. And then I'm going to divide this by 2. So this is actually the square root of 7/24. And I don't really want to leave it this way because actually there is a perfect square factor that goes into 24. This is the same thing as 6 times 4. So this would be the square root of 7 times the square root of 6. All right. So 2 square root of 6 is on my denominator. This is 24, 6 times 4. Now when I need to rationalize the denominator, now I want to multiply it by square root of 6 over square root of 6. So this is the square root of 42 over 2 times 6 is 12. That one was a little messy. Now if I'm looking at cosine of a half angle, that formula, if I know cosine, I'm going to just use the formula that has cosine in it. This is going to be 1 plus cosine of the angle is 5/12. So again, this is 12/12 plus 5/12. This will give me 17/12. Divided by 2, which is the square root of 17/24. So this would be the square root of 17 over 2 times the square root of 6. And if I rationalize my denominator, square root of 6 over square root of 6, this gives me 6 times 2 is 12. And 17 times 6, let's do 10 times 6 is 60, 7 times 6 is 42, so that's 102, square root of 102 over 12. Now 12 is not underneath the square root sign. Okay, we rationalize that denominator, and 12 is actually a real number instead of, it's a rational number instead of an irrational number. All right, so hopefully that was good for you, and hopefully you're ready to take the Part 2 test.